Welcome to lesson 6003 of Pre-Calculus Prerequisite Skills, or Unit 0. This is the basic properties of algebra. So let's first start with terms of algebra. What are terms of algebra? Okay, so a variable. We know a variable is a letter or object representing a number. So usually in algebra, we will use the letter X. We know a constant is a number. A constant like 3, when x equals 3, you get some type of straight line. When y equals 3, you get a different type of straight line. So a constant is a number and is always that number. A constant has no variable. And the algebraic expression is something like x plus 3 or negative x or something like that, where you have a letter doing some type of math, whether it's addition, subtraction, multiplication, division, to a variable. These are algebraic expressions. 2x, x over 10. These are all algebraic expressions, believe it or not. Addition, we know how to add, we know how to subtract, we know how to multiply, we know how to divide. Let's talk about reciprocal. Reciprocal, I told you before in the previous video, if you take a number, a whole number, or a natural number, or a counting number, you can turn it into a rational number by putting it over 1. Now, here we are with this number. Reciprocal means to flip a fraction upside down. That's what the word reciprocal literally means. So when I say the reciprocal of 7, I'm talking about 1 over 7, which is also called the multiplicative inverse. Inverse means something has been turned upside down. So a reciprocal, if I multiply these two fractions, I will get 7 over 7, which is 1. If I add them, I won't get 1. So we're going to talk about this, why I did what I did here in a couple of slides. Now, let's talk about some basic properties of algebra. Commutative, commute, means to go back and forth. When you add and multiply numbers, you can switch the order of the numbers. It just does not change the value of the numbers. So 3 plus 5 is the same as 5 plus 3. 3 times 5 is the same as 5 times 3. You switch the numbers, you don't change the value. Associate. Who do you associate or group with? You can group numbers when adding and multiplying them in different orders, and you don't change the value of what's being done. The identity property. If you add 0 to a number, you get the same number. If you multiply 1 to a number, you get the same number. So there's an additive identity property and there's a multiplicative identity property. And finally, the distributive property. When a number is next to a group, and a parenthesis, believe it or not, is a grouping, you have to distribute to all terms in the group. The A, because it's next to a parenthesis, has to multiply to every term in the group. And that's why the A will distribute to AB, make it A times B and A times C. Whenever letters are next to each other with no sign in between them, the order is multiply. Whenever you have a letter next to a number, it's 3 times A. That's how we read 3A. It's 3 times A, technically. But we just say 3A because we understand that those numbers are multiplying. That's the order of operation. And then math. All you do in math is add, subtract, multiply, divide. You have to do one of the 4. Sometimes you do multiples of them in the same problem, but you have to do one at a time. Okay, let's talk about the inverse property. So for every A, there is an additive inverse, or it's negative. So if I have 3, if I add negative 3, I get 0. And you see the examples down at the bottom. The inverse property of multiplication. There, for every number that's not 0, because we can't turn 0 upside down, there is a multiplicative inverse or a reciprocal such that 1 over a gives us 1. So 5 times 1 over 5 equals 1. That's inverse. Okay, let's move on to exponents. What are exponents or powers? What is an exponent? An exponent has two parts, a base and an exponent, or is sometimes called powers. Your powers. So this is called condensed form right here. When you see a base with an exponent, it's called condensed or standard. Condensed or standard. And this is an expression. You had to do something with it. This does not mean 3 times 2. The 2 tells you how many times to multiply 3 to itself. So over here, you have your standard form, and then you have your expanded forms. So 3 squared equals 3 times 3. 3 cubed means 3 times 3 times 3. 3 to the 4th tells you how many 3s to multiply to each other. People get that confused. They do 3 times 4 and get 12. And that is not it. Here are exponent rules. You're going to need to refer to this and memorize these things. There's one more rule I need to write down that's not on here. When you multiply the same base, add the exponents. When you divide the same base, subtract the exponents. So that's the product rule and the quotient rule. When you raise a power to a power is a base and an exponent. When you raise a power to a power, multiply the exponents. When you have two different products, distribute the exponent. So if I have a to x times b to the x, and they both had the same power. So if I have 3 squared times 4 squared, I can multiply the 3 and the 4 to get 12 squared. It's the same thing. 9 times 16 is the same as 12 times 12. Now, if I have 3 squared times 4 squared, I can put them together and square them separately, and that's how I got 12 squared. So I just went backwards and forwards with that one. So same idea, but with a fraction. If I have an exponent outside of a fraction, I can distribute that exponent top and bottom to the fraction. Any number except 0 to the 0 power is 1, a 0 exponent. Negative exponent. Any exponent with a negative goes across the fraction line. How do we know? So if I have 7 over 1 and I have raised it to a negative exponent, it becomes its inverse or a reciprocal. It becomes 1 over 7. Now, what if I have 1 over 7 to the negative 1? Well, again, I still flip this upside down to 7 over 1. Now, if I get more numbers, I had to do something else. Then a fractional exponent. The numerator is the exponent, and the denominator is the root. Okay? So if I take a fractional exponent like a, I should have put a number near, to the 3/4. What this means, the denominator means the 4th root of a cubed. So your numerator in a fraction becomes the exponent, your denominator becomes the root. And there's one last one that I couldn't fit on this page, so I'm going to tell you that I couldn't find. Anything written is to the first power. Any number with no exponent has an exponent of 1. Mathematicians are lazy. They don't like writing 1s, and they don't like writing 2s on square roots. So we know that a has a coefficient of 1, but it also has an exponent of 1. Mathematicians just don't like writing 1s. It's redundant. And finally, scientific notation. Scientific notation is writing a way of writing exponents, but you're dealing with base 10. So your a part, your base part, is also called the base, ironically, has to be between 1 and 10. It has to be greater than 1, Greater than or equal to 1, but less than 10. It can't be bigger than 10. It can't equal 10. Must be less than 10. So, and then you multiply by 10 to some integer, positive or negative. B can be positive or negative when dealing with bigger numbers. So let's show you how this works. Now, on the calculator, you have to hit the second button and a comma, and you will see E pop up. Or maybe you'll see a capital E. I think you see a capital E pop up. Now, sometimes you'll do calculations and you'll get something like 2.371 E6. What this means, E means times 10. So it's 2.371 times 10 to the 6th power. That's what E means on the calculator. And how you access the scientific notation, the second comma. The comma is over top of the 7 button. So what does scientific notation do? Scientific notation deals with numbers that are very big and very small. What we had to do is basically the 6 tells us move 6 to the right. So to go from scientific to a number to a notation, we move the decimal point 6 times to the right. 1, 2, 3, 4, 5, 6. We put 3, 7, 1 in the humps. And for the rest of the humps, we put zeros. And our decimal point goes to the end. And that's what this number is. It's 2.3 million, which is a large number. Or conversely, we could deal with very small numbers, like 2.758 times 10 to the negative 8. Now, this will show up on a computer if you did a calculation as 2.758 E negative 8. And you had to translate that as 2.75 times 10 to the negative 8, which means you have to move the decimal point 8 places to the left. 1, 2, 3, 4, 5, 6, 7, 8. And so we would have 7 zeros, 4, 5, 6, 7, 2758. This is the number in standard form.